Yes, sir. Kind of just blow up for me.
Okay, let's get started. Today is the 22nd, and we're only like, what, an hour away from vacation, is that true?
Yeah.
Unless you guys have classes tomorrow. Does anybody have classes tomorrow?
Heck no.
Oh, okay, just checking. And then when we get back, we finish chapter 6, and then you get your quiz. Right after that, over chapters 4 and 6. Now, I want to mention something. I asked several students how long they prepared for that last quiz, because, how they did, just so I could have a feel for it. And it's, to me, the answers led me to believe that it was not as hard of a quiz, that the first quiz and second quiz were both semi-challenging, but not difficult. So, I'm going to challenge you on this third quiz. I want to prepare you. But I'll take it easy on the fourth quiz and the final in trade. Alright? Because, some people said they only prepared from 1 to 3 hours for that last
No,
quiz.
we take that back. It took us like 5, 6.
Okay, so what I'm trying to say is that I want to challenge you. This next quiz will just kind of separate the A's from the B's a little bit, and then from there you should take a nice deep breath. But be prepared for this quiz. Even though I think this chapter 6 we're about to go over, I don't think you're going to have to do a lot of studying for the quiz for that one, because I'm going to break this chapter down to a point to where it's going to seem very easy to you. And then it's chapter 4 you just got to worry about. Oh, I need one person. Okay, we're going on to chapter 6. Are you ready? Transportation model. We're going to try to get through 3 of them today, and 2 more then when we get back, and then it's your quiz. And these models, the transportation problem, assignment problem, transshipment problem, I remember when these were just starting to hit the industry, and this was a big deal. And where companies really said, wow, this is really going to help us save money is when it came, I worked for this company down in Ohio called Artesian Industries. And our claim to fame that really won over customers is we were one of the few manufacturing companies that would ship directly to our customers and bypass the distribution centers. That we would make our requirement of how many to ship to get it directly from the manufacturer small enough that the average business who would want to buy our products could get it directly from the manufacturer and save money. And this company I worked for made bathroom, everything you can think of in the bathroom. Tubs, tub surrounds, commodes, vanities, sinks, faucets, everything. And that was our thing. And so we had a logistics person, but she wasn't called logistics. The word logistics wasn't really familiar back then. She was our shipping coordinator is what we called her. And I'm telling you, she was like a genius. She was all about making sure that our trucks would be heading out in these circles to hit the customers to make sure the cost of shipping is as low as possible. But she didn't have a software like this to do it. And that's what these do, is help you figure out the shortest route, the least expensive way, how many should be shipped, because we had 3 different locations in Mansfield, Ohio that we were shipping from, not just one, and where it should be shipped from, to which customers. And it was all about the packing these trucks from top to bottom, making sure the last delivery was at the front of the truck and the first delivery was at the back. Now here's where she made her money. She would find businesses after that truck was empty and trying to make its way back. Instead of coming back completely empty, she would find businesses that needed to ship to Mansfield, Ohio or near Mansfield, Ohio, and she would have our trucks picking up things on the way back. That's what logistics is all about now. Every company's caught on to how much money they can save to using these kind of things and planning things in advance and making sure you can try to create shipping as low as possible and not waste money. I remember when our warehouse went on strike, and we all, the management, had to go and work in the warehouse, and I had never driven a forklift, and I almost destroyed one of our trucks. Because I had never driven a forklift, I didn't know what I was doing. We're just all trying to help out so that we still have some revenue coming in to meet expenses while this strike was going on. It was a crazy time. So I learned a lot about how the the whole trucking and loading of the truck and all that took place, and how important it is to have it loaded all the way to the ceiling of the back of that trailer in order. It was all figured out how it should be packed, which box was which size, and which order it should be in at the bottom all the way to the top. And that's how a lot of businesses do it. We were a national manufacturing company, so it was that organized. So with that said, let's get to the fundamentals. The key of today's lecture is to make notes of the hints I give you that will make each one easy. We'll start with transportation. I'm going to say stuff like, here's what a node means, here's what an arc means. And these are the kind of things you want to put in your notes, because when you see this on a quiz, you go, once you can recognize, is this transportation, is this assignment, is this transshipment? I want you then to jump to these notes you're taking right now and say, okay, every node is a constraint. And then you'll look at it and go, okay, there's 5 nodes, there's got to be 5 constraints. These are the things that will get you to the answer fast. All right, let's start with this. How many nodes do you see? Nodes are the circles. Every node is a constraint on transportation problems. How many constraints are there going to be?
5.
You've got it. How many arcs? Now, in transportation, arcs are going from where things are being shipped from to where things are being shipped to. And the arcs represent that, yes, if we decide to ship from this location, it can be delivered to that customer. If there were no arc there, that's saying, no, this place cannot deliver to that customer. In this particular situation, how many arcs do you see? 6 arcs. Every arc is a variable. So how many variables? 6. Now, when I see a problem like this, because there's 6 arcs. 1, 2, 3, 4, 5, 6. Every arc's a variable, and there's only 6 arcs, so 6 variables. Okay? So there's 5 constraints because of 5 nodes, 6 arcs. This is representing where we can ship from. This is representing where we have to ship to. The numbers on the outside are very important. This is what the demand is, or what the orders are for these locations where we have to ship to. That's what's on the outside here. On the outside of these nodes on the left, this is how many we could ship if we need to. And this one would be how many we could ship from this location. Now, we don't have to ship everything. We have constant orders coming in. So when you write constraints for the nodes that represent where it's being shipped from, these constraints are always less than equal. Because we don't have to ship everything. And they're always less than equal the amount that could be shipped.
One more time.
You ready? The constraints for the nodes as to where it's being shipped from, which are the left side, is called the sources, are always less than equal constraints. And it's always less than equal to however many could be shipped, which is the number right outside the node. So if this were 200, it'd be less than equal to 200. If this one was 100, it'd be less than equal to 100 for this one. All right. Destination nodes. They have numbers on the outside as to what the orders are from where we're shipping to. Let's call them customers for right now. And these constraints are always equal to the number that's being ordered. Equal, equal, equal. So you got the right-hand side of the constraints figured out. Okay, you ready? Let's go back to any of these nodes. When you're writing the constraint, the left-hand side are the variables being added together that are touching the node. Let me start with this first node right here on the left. We could ship from this warehouse. There'll be a certain amount here we could ship, but how many arcs do you see touching this node? 3. That means there's going to be 3 variables added together, less than equal to whatever the amount is we could be shipping. How many variables will be on the left side of this node number 2 on the left side? 3. Added together, less than equal to whatever that is. Let's go to our customers or wherever we're shipping to. How many variables are touching the top node here? 2. That means there'll be 2 variables added together equal to whatever the order is from this customer. So this destination or wherever we're shipping to. How many variables on the left side of this constraint? How many variables on the left side of that constraint? You got it. Now, this is where everybody accidentally makes an error. These numbers that are going to be on these arcs, right now they're letters, this is the cost per 1 unit if we were to ship from wherever the arc starts to wherever the arc is going to. That is the cost per 1 unit to ship it. And these costs that are going to be on these arcs are only used in the objective function, only on transportation. You ready? These costs that are going to be on the arcs are only used in the objective function. None of the constraints will have the costs involved. Just the objective function when it comes to the transportation network. Everybody hear that? Okay, I just want to make sure you get this. I'm going to write the first constraint if we were to ship from our first warehouse. Are you ready? I use the letter X, and you'll notice on the PowerPoint, almost all of them are X. And then the two little numbers next to the X is the first one's where is it coming from, the second one's where it's going to. And notice I numbered my nodes 1, 2, 1, 2, 3. You can number them any way you want. 1, 2, 3, 4, 5, or 10, 11, 12, 13, 14. It's up to you. But here's how you write the variable. I'm going to write this constraint right here. x11 plus x12 plus x13 less than equal to whatever that number is there. That's the whole constraint. When everybody's ready, I want you to do this one together, if you don't mind. Mike, or you want to do it by yourself? I can tell. Yes, I can tell.
Please.
Are you sure? All right, help me out with the variable. I'll start out. X plus X plus X less than equal to whatever that number is. Got it? All right. I'm going to do this. I'm going to write this constraint for this customer node right here. It's almost exactly like you did except for the end. X11, don't forget the numbers always go from left to right, even if you're over here. X11 plus X21 equals whatever that demand is. That's the whole constraint. This one's going to be 2 variables equals the demand. This one's 2 variables added together equals demand. This one would be, help me out, X, you got to go left first. 1, 3 plus X
2, 3
equals whatever that number is. You got it. Okay. The objective function is either a max or min. We'll talk about that in a minute. And it is each variable added together, but with their costs involved. For example, let's say this is a min, because we're trying to minimize maybe the cost of this shipping that we're about to do. So min, x, or I'm sorry, number x11 plus number x12 plus number x13 plus number x21, blah, 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 blah. 6 arcs, 6 variables being added together, but with their costs. That's your objective function. That whole problem's done as far as the constraints and objective function. It's exactly, if you get that down, these are very easy. Let's do our first example. Acme Concrete Company, they have orders for 80 tons. 25 tons needs to go to Northwood, 45 tons to Westwood, 10 tons to Eastwood. These are our customers. I'm putting them over here. Let's see, this is Northwood, this is Westwood, this is Eastwood. I'm going to number them. I'm going to make that a 1, a 2, and a 3. And Northwood is asking for 25 tons. Westwood is asking for 45 tons. East is asking for 10 tons. Now it says Acme has 2 plants. Each can produce 50 tons. So here's one plant, here's the other plant. I'll number them 1 and 2, 50, 50. Now we don't know yet if each plant could ship to any of those customers yet. We're not sure. Says delivery cost per ton are on the next slide. How should these be shipped for the week, for these orders? Here we go. I see that plant 1 has a number for every one of those 3 locations that we need to ship to, which means it can ship to any one of the 3. If you saw a 0 or a blank here or here or here, it's telling you that we cannot ship from that to that. That's what a blank or a 0 means. You can't do it. And you would not draw an arc on the drawing then. You leave that arc off. But in this case, we can go from this to this, and our costs are 24, 30, and was that 40? We can go from the second plant to any one of these customers. All 3 of them are available, and our costs are 30, 40, and 42. Don't forget, this is a micro. I can look at this and already decide what the shipping should be because we want to keep our costs as low as possible. But this is such a micro to the real world. I mean, in most cases, you may have 2 or 3 places you're shipping from, but you're going to have about 20 over here. And not all of them can be shipped. And so it's not as easy just looking and go, oh, well, this is easy. And you instead use the math, and you can quickly come up with the least expensive way to get these goods shipped and meet those customers' orders. So help me write the constraints. I want to start with this node right here. I'll do it myself. Are you ready? I got x11 plus x12 plus x13 less than equal to 50. Does that sound right? I see 3 arcs there, so I knew there was 3 variables. I'm just following the arcs. Always the first number is where it's coming from. Second number is where it's going to. The next one, help me out. X 21 plus x 22. No, that's not right, is it? Okay, just checking. Plus x 23 less than equal to 50. There's our supply constraints. They're done. Now I'm going to use our customer. I'm going to do our customer constraints. I see 2 arcs going to this first customer, Northwood or whatever. I'm calling it 1. So I got 1, 1, 2, 1. So x11 plus x21 equals 25. I'm going to do the next one real quick. x12 plus x22 equals 45. And the last one, got to look at it a second here. x13 plus x23 equals 10. Now, here are some, I always check this to make sure I have this in the right order. I know when I'm writing supply constraints that the first number should always be consistent because it's where it's coming from. It represents where it's coming from. Here's another supply constraint. The first number is consistent, 2, 2, 2, 1, 1, 1. When I'm looking at destination destination constraints, I know the second digit has to be consistent because that's where it's going to. 1, 1, 2, 2, 3, 3. And that's kind of my check, and that's probably how I grade them too. That's how I'll check to make sure you wrote them out. Just check that you have consistency on the first number and on the second number on the destination. You ready for the objective function? Min or max?
Min.
Min, because these are costs. How many variables would be in our objective function? 6, because there's 6 arcs. I'm going to use the cost. 24 times x11 plus 30 times x12 plus 40 times x, was that 13? Yeah, it's got to get it better. Plus 30, 40, 42. 30 x21 plus 40 x22 plus 42 x23. Does that look right? There you go. We're done. Just enter it in and solve it. What? 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 You did it already. Okay. You ready? Plant 1, 24, 30, 40 can provide up to 50 units. Plant 2, 30, 40, 42, 50 units. Northwood's demanding 25, Westwood 45, Eastwood 10. Right here's where our optimal solution is going to be. Tell me this is posted. Is this posted? Anybody on course content?
No.
It's not? If you remind me, I will make sure and post this, and you can take it, just change it, and use it. All right? Because this is a little different than the ones we've done so far. Now, down here, This is the formula. You can write that way, or you could have done it individually. And then down here is the weird part. These cells just have zeros in them because this is where our optimal solution is going to appear. It's going to tell us how many to ship from Class 1 to Northwood in order to optimize our cost as low as possible and still fulfill that order. These numbers here are how many could be shipped. These will be less than equal. These numbers here are how many are being ordered by each customer, and these have to be equal to those numbers. And that's your constraints, basically. This is just adding those. This is just adding those. That is adding these. So if I click on this, you'll see some of those 3 cells to the left, and you go down here, some of those 2 cells above it. Just the sum of them. But how you fill in solvers, the trick on this one, because it's a transportation problem. You ready? Data, solver. Hey, don't look. You got to pretend we don't see it yet. Hang on, let me get it out of there. Even if you take it out of there, it just keeps it reappearing. Hang on. Delete. Okay, here we go. Set objective. The hint I always gave you is, where is the objective function being calculated? Right here at E17. This is a min, so I'm going to make sure min is clicked. Changing variable cells. Here's the trick to this one. The optimal solution is right here. Those 6 cells are where you want the optimal solution to be placed, because there's 6 decisions. How many should be shipped from? 2. Right there. So that's in place now. Subject to constraints. Let's add a constraint. This is where we're going to take, we can do all 3 of these. Here's our left side. We want these cells to be equal to. These are these. Equal, equal, equal to, let's do the right side, 25, 45, 10. Right there. Let's add another constraint. That will be these 2 cells less than equal. We're doing this right here. The right side would be these 2 50s right here. Hit OK. There is our equal cells for the demand. There is our less than equal for supply. Simplex, da-da-da-da-da. You ready? Hit there, hit OK. Let me scroll down. Hey, what happened? Well, where did our, did it just close? Oh, I don't know how that happened. You ready? We should be shipping 5 units from Plant 1 to Northwood, 45 from Plant 1 to Westwood, 20 from Plant 2 to Northwood, fulfilling their 25, and 10 to Eastwood from Plant 2, fulfilling that 10. What is it going to cost us to do this shipment? That's right, $2,490, and that's as low as we can get it. Too easy? We're done with transportation. Let's go to the next one. Oh, wait. Northwood, from Plant 1 to Northwood 5, Plant 1 to Westwood 45, Plant 2 to Northwood 20, Plant 2 to Eastwood 10. $22,490. Skipping this one, we're going to assignment. Very similar. Very similar. You ready? For assignment networks, every node is a constraint. Heard that before. Every arc is a variable. Now, what you don't see on this drawing should be ones on the outside of every node. So 1, 1, 1, 1, 1, 1, and that must be included if you're asked to draw this network. A 1 on the outside. This is used, for example, at large CPA firms or lawyers' offices, or where they're constantly assigning employees to jobs, for example, tasks they call it. And it's a matter of maybe they want to figure out how they could have the largest revenue. This is unethical kind of, but the law office may say we want the most billing hours we can get, or the most revenue based on the billing rate that we could charge. So who should we assign to which tasks? We got these 3 jobs, we got 3 lawyers. which one should be assigned to which one, and they may say, on these costs, maybe the hourly cost that they could bill. And a law firm's all about what's the most we can get in revenue, so this would be a max then, if that's what it was. This is a CPA firm. Could be that, or let's say the CPA firm is trying to, this would be if there's a whole bunch of them, but they know they have to reimburse the accountants that are going to go do the audits, and they have to reimburse them for mileage, and they want to keep that cost of mileage down as much as possible. This would be the cost per mile they'd have to reimburse to each accountant that they assign to the job, and they're trying. And maybe they're saying, okay, the accountant's going to be going from their home directly to the audit and not to the office, so it could be then the amount of miles. Because maybe it's just one price per mile and they're trying to keep miles as low as possible. That would then be a min. But it's always what employees or what agents or whatever this is on the left side that's available. And on the right side is the jobs or tasks that have to be done. These are our client's requests. So these nodes, these constraints are always equal to 1. The left side is always less than equal to 1. Well, I just thought of something I forgot to tell you about transportation. I'm going to go back maybe. But right now we're staying on here. The deal with assignment is that you will not be able to solve it using Excel, and you won't be able to solve it using the software if you don't have enough agents to fulfill the jobs. You either have to have as many on the nodes on the left side as you do on the right side, or more. If you don't have enough nodes on the left side, let's say there's only 3 employees, but we got 4 jobs, you must add another node and call it, in the book they call it the dummy node, because it's not a real employee or not a real whatever you're assigning. But it allows you to calculate a solution. And the dummy node, whichever client gets assigned the dummy node, is not going to have anybody there. That means that's the client that has to go without. We'll have to push that job forward to another week or whatever the situation may be. But you can't solve it unless you have as many left-hand nodes as you do right or more. Now, if you have more on the left, there'll be 1 or 2. The extra ones won't be assigned, and that's fine. You're just trying to figure out what would be the best solution to make sure the customer's needs are met, whatever it is you're trying to maximize or minimize, cost or revenue or whatever it may be. The left-hand side, just to repeat myself, less than equal to 1, always. And the right-hand side, equal to 1. Each arc is a variable. The variables are expressed the exact same way as transportation, x11, x12, x13. The costs, whatever these represent, the numbers on the lines, whether it be a positive or negative, or cost or revenue, they're only in the objective function. None of the constraints should have these numbers on these arcs. The constraints are the variables by themselves with no numbers, no cost or profit numbers that are on these arcs. How many variables do you see in this problem? 9 variables. How many constraints altogether? 6 constraints, right? All right, here we go. The general contractor has this construction going on, and he or she has to assign the subcontractors for the electrical, but there's only 3 projects, and we have 4 subcontractors. So we have to decide which one of the 4 contractors will get assigned to each one of the projects for this next day. And the general contractor's biggest concern, which seems pretty odd, such a small point, is reimbursing for mileage, believe it or not. So what you're seeing here is the amount of distance in miles that if we assign that subcontractor to that project, that we would have to reimburse them for. Minimize or max, you think? Yeah, we're trying to keep these miles. And as you look at that, you're going to go, oh, 14's our lowest one. We're probably going to have Universal go to Project C, right? But that could cause us to have to spend 50 maybe on another one because it's not available to do that one. So this is these. You got to remember, this is usually a much bigger. This is micro, but using the math will allow you to make sure that you're keeping that cost, whatever it is you're trying, your objective is, as low as possible, and will tell you the best assignment. So we have 4 subcontractors, 3 projects. If we were to draw it out, oh, I think I got this wrong. Looks like this. Now, everybody hear this, and whoever's watching the video, there must be ones on the outside for this to be correct. Ones on the outside of each node. All right? Who feels like they're getting this? What do we want to call these? Let's leave these letters. W, F, G, and U, and then A, B, C over there. I'm going to write the constraint for the top left one here for west. You ready? This is the constraint. And I know there's a 1 right on the outside of this, so here we go. XWA plus XWB plus XWC less than equal to 1. There's the constraint. Because there's 3 arcs, 3 variables. I want to just know that you're getting this. So we're jumping down to G here. Help me out. X, GA plus X,
GB,
B, GB plus X,
GC,
GC less than equal to 1. There's that constraint. This one would be XFA, XFB plus XFC less than equal to 1. This one down at the bottom would be XUA plus XUB plus XUC less than equal to 1. Now remember, if for some reason this one cannot be assigned to a project, there would be no arc there. And that variable then would not exist on the left side of the constraint. And to know that if one of these subcontractors can't be assigned to one of these jobs for whatever the reason may be, there'd be no number there. And you would know not to put that arc in and not to include it then in the constraint or the objective function. Speaking of the objective function, how many variables will be in the objective function? No. 12. Thank you. There's 12 arcs. It's always about how many arcs. Always. Now, let's do one of these constraints. I probably don't even need to do an example. Anybody want to volunteer just to spit it out? Thank you. Hang on, Kimberly. Wait, I'm going to start over. Go ahead. X. I'm sorry. What's that?
Yeah, sorry.
Go ahead. X. No, it's always from where our.
Sorry, from up.
Marco's jumping in. Marco's. Okay, he gave you the green light. Go.
XWC
Plus.
XFC
Plus.
XGC
Plus.
XUC equals 1.
There you go. That's exactly the constraint. That's how this one would go and this one would go. It's that easy. I can't make this any easier. All right, that's about as easy I can figure out how to make it. So you're going to have 7 constraints, and then you have the objective function. And then you told me there's 12 variables, so all 12 variables will be in the objective function, but with the corresponding number that represents what we're either trying to max or min. This one a max or a min? Min. I'm going to give you the objective function real fast. Are you ready? The min, 50 XWA plus 36 XWB plus 16 XWC plus 28 XFA plus 30 XFB plus 18 XFC plus 35 XGA plus 32 XGB plus 20 XGC plus 25 XUA plus 25 XUB plus 14 XUC. That's the objective function.
One more time.
No, it's right here. It's right there. It's right there. It's right there. I'm just trying to show you, though, how easy these are. Once you get the process down, it applies to every single one of these. And this is if they're numbered, you guys. If the left-hand side were 1, 2, 3, and 4, and the right-hand side is 1, 2, 3, all I did is I used letters. So. Is everybody getting this so far? We doing okay? Let me see how we're doing that time. Because we got this huge in-class time. Just kidding. Right here, less than equal, the 4 nodes that are on the left, equal, the 3 nodes on the right, correct? There were 4 arcs touching the nodes on the right. There were 3 arcs touching the nodes on the left. You have this right in front of you while you're taking the quiz. You can imagine you're going to have a little story with some numbers, and you're going to have to put either together the drawing or the objective function and constraints, or both. Right? What? You just realize how easy it is, though, right? Okay, I know you guys are going to kill a bunch of brains over vacation. Watch. I'm making it so easy, though. You're going to be able to come back to this when you watch the video, right? And you'll all come back to you finally. Ah, I'm sobered up. Let's watch the video. Here's our sign. Oh, wait, what am I doing? Almost forgot. Yeah, is it going to remind me to post an example of transportation? Yeah.
No, you said
no, you got something to tell us about the phone.
Oh, yeah, about transportation. Yeah, I'll go back to it. Hang on, I got to try to remember what I'm doing here. 50, 36, 16. Okay, so which one is this? 50, 36, 16. Must be this one. There we go. If I were to open this up, look at your programming, I'd put the variables across the top. 1, 1 would be the left-hand side number 1 to the right-hand side number 1. There's the numbers in the objective function. Here is x11, or whatever the letters are. x11, x12, plus x13, and if I went all the way over, it'd say less than equal to 1. Let's look at the right side. How do I get over here? And I'm forgetting how to scroll that over. There it is, there it is. There we go. Less than equal to 1, less than equal to 1, less than equal to 1. There's 4 of those. Equal to 1, there's the bottom 3. And then you would hit solve, solution, solve. Now you tell me, is agent number 2, our second subcontractor, going to be assigned to a job, and if so, which job? Come on, I can almost hear you. Job A, the first job. Because if you look at where the 1 is, it says X21. That's the second agent going to that first job. That second subcontractor going to the first job. So I'll go back here. Whoop, whoop. Hang on. Right here. The second subcontractor going to the first job. There's 28 miles right there. The second subcontractor going to that first job. Look at the output now and tell me. You already given me ideas for the test. Maybe I just put an output there and you tell me who's being assigned to what. I want to make sure you get this. I hear a lot of hesitation in your voices.
So you're saying then, so X.
Well, who's going to be assigned to the third project? That was my next
First
one.
contractor.
The first contractor is? You sure? Because of 1-3. Is that there was only 3 projects, so that makes sense. So he's saying 1-3, which would be West being assigned to C. Which subcontractor, go back here, whoop, whoop, hang on. Which subcontractor is not getting assigned to a job? So say it again, I heard it.
3.
Number 3, the third one, because if you notice, 3-1, 3-2, 3-3 has no 1s. Contractor number 4 has a 1. Contractor number 2 has 1. Contractor number 1, but number 3 has no 1. Not assigned to anything. See that? Now I want to show you a shortcut. Hang on a minute. Where am I here? Are these the same numbers? All right. Hang on. Let me open this up. You ready? There's another module on here other than linear programming called assignment module. You can click on that one, say new, and it's going to ask you how many agents, how many subcontractors were there we have to schedule? 4. How many jobs were there to schedule? 3. And then you hit OK, and it's asking you to fill the table in. Right there, and when you fill it in, it looks just like that. If agent number 1 or subcontractor going to the first job be 50 miles, if the first contractor is going to the second job, 36 miles, and so on. Then you hit solve. Max or min, are we max or minimizing those miles? Min. And it says, all right, agent 2 is going to be assigned to that first job, agent 4 to that second job, agent 1 to the third job. 69 miles is as low as we can get the miles for the cost of reimbursing these subcontractors. And agent number 3 is not assigned to any job. So that's another option available on the software also. So I showed you how to do it. Now, we're going back to transportation to pick up on something I forgot to tell you. All right, this is a tough one to show you here. This is in transportation. It's even tougher. Okay. On this, the thing I forgot to tell you is, on that concrete one, this one could supply 50 and this one could supply 50, right? And this was like, do I still have it here? 25, 45, and 10. 25, 45, and 10, what does that add up to? 40, 50, 60, 70, 80. So we have more than enough to be shipped, and we're not going to ship it all, obviously, because there's only 80 in demand. In transportation, you ready on your notes? If demand is more than what could be supplied, the only way you can solve it is you got to add a dummy supply for the additional amount to meet demand. Everybody hear that? Let me give you an example. This is hypothetical. I'm changing the demand. I'm going to change it to 30, 100, I'm already 20. This adds up to 150. I didn't mean to go 150. I don't want to confuse anybody. Let me change it to 40 now. Now we're at 160. But all that can be supplied is 100. So, in order to do this, you got to add a dummy supply, and you got to put the amount that will get you to at least equal the demand. 40, 160, we got 100, so this one's going to have to be 60. You put your arcs in, and the cost, this is a minimize, the cost are 0. Because they're 0, you don't have to include them in your objective function. They'll have, because they're 0, but these arcs must be in each of your constraints. So we would have to rewrite this constraint, this constraint, this constraint, and add x, what is this, 3? 3, 1, x, 3, 2, and x, 3, 3 within these constraints. When you get your solution, wherever anything that's supposed to be shipped from here is your back order. And you're notifying those clients, I'm sorry, but these 60 units are on back order. You have more ordered than what could be supplied. And this is telling you who gets the back order and by how many. Could be 2 clients getting a back order, 30 and 30 or something like that. So I just want to make sure you understood what I did. If demand is more than supply, you must add a dummy supply with the amount available to meet demand. If it's a minimization, the cost would be zeros. If it's a maximization, these numbers would be some huge number that they would never get picked. They get picked because they have to get picked, and it's your back order. Get it? And then you would have to include them in your objective function. So because they're zeros, you can just, if you want to include them in your objective function, it'd be 0 times x 3, 1 plus 0 times x 3, 2. But when you multiply anything times 0, it's like it doesn't exist anyway, so there's no reason to put them in your objective function. But if you did, I wouldn't count it against you at all.
If it was a minimization problem and it represented cost.
That's right. Those are going to get selected first, but it's still your back order. Somebody has to get the back order.
Okay.
Somebody's going to have to get back. It doesn't change this. If you don't make them 0, your objective function value would be off. It would be so far off. You have to make them 0. It's just assigning the first 60 instead of the last 60. I used to think the same thing. So I knew you were going there. But I like what you're doing there. She's going to prove on that last one too that it can be solved different ways. I hope you do. Okay, so we reviewed that, so we know what we're talking about. We have one last one before we're on vacation. Is that correct? Transshipment. Here's transshipment. Now all this looks worse than it is. Right? I gotta take attendance.
He's taking it home.
Need a sign-in sheet. All right, you ready?
But wait, the people who gave you homework,
I was born, but not yesterday. You ready? I'm on my 28th and a half year. I've seen anything and everything. Are you ready? This is very much like transportation. Very much. The left-hand side is everything I told you about transportation applies to transshipment on the left side, applies to transshipment on the right side. Just to make sure we're on the same page, if I were writing the constraint for this destination right here, would that constraint be less than equal, greater than equal, or equal?
Equal.
Exactly. This is just like transportation. How many variables would be in this constraint right here that's equal to whatever that demand is? Because there's 3 arcs. This one, 3 variables, 3 arcs. Going back over here to what supply, where it's coming from, this would be less than equal, less than equal. How many variables in this constraint? 3 arcs. How many variables? 3 arcs. Same thing, what I said, don't put the costs in any of the constraints. These cost numbers on these arcs are for the objective function only. Everything's the same, less than equal, equal. The only thing that's different now is the center. When does transshipment, how is it used in the real world? Any business that ships first to a distribution center, then ships to customers, that's transshipment. It's going to one place, breaking down the goods to smaller bundles, then shipping to the customers. That's what our transshipment is used. Walmart, tons of distribution centers all over the place. Right? And a whole bunch of other companies that just didn't pop in my head other than Walmart. Here's your center nodes, the distribution centers. The arcs coming into them is everything being received. Anything that's received into a center node, which is a distribution center or whatever it represents, has to also head back out. So every one of these center nodes are always equal to 0. On transshipment, the center nodes constraints are always equal to 0. There's the rule for transshipment. That makes it different. Now here's the weird part. Look at node 3. And by the way, when you number these, do not make the mistake of going 1, 2, 1, 2, 3, 1, 2. Because when you talk about X11, you don't know if you're talking about from 1, 1 here or 1, 1 here. With transshipment, every node has to be labeled differently or it won't make sense. You can use numbers or letters, but every node has to be labeled differently. You can't have a 1, 1 or a 2, 2 or anything like that. Now, these center nodes I said are equal to 0. How many arcs do you see touching node 3? How many? Boy, I see 4. All right, 4. The arcs are always described from left to right. So I see X13, I see X23, I see X36, I see X37, right? And if I were over here, don't make the mistake of calling this X63, because it's always from where it's coming from to where it's going to. That's X36 here. That's X46. That's X56. Equals whatever the demand is, if I were writing that constraint. These middle constraints are all equal to 0, and you have to make the variables, without any of the costs, the variables, either the ones coming into the middle node as either negative or positive, as long as the ones leaving are the opposite. And you must be consistent with each middle node. Let me say that again. For example, if I were going to write the constraint for this node, maybe I want to make the ones coming in positive and the ones leaving negative. So I would say X13 plus X23 minus X36 minus X37 equals, help me, 0. Now, once you do one middle node and you determine whether you want to make the ones coming in positive or negative and the ones going out the opposite, you must be consistent with any other middle nodes. You can't switch it up all of a sudden. So as soon as I establish that I'm making the ones coming in positive, the ones coming into this center node must be positive. The ones coming into this center node must be positive, and the ones leaving negative. But the person next to you could do it the opposite. The ones coming in negative, the ones leaving positive, but they have to be consistent. The ones coming in negative, the ones leaving positive, the ones coming in negative, the ones leaving positive. Let's do a node constraint with the ones coming in negative. I'll start it off, but you help me through it. Here we go, the ones coming in negative. Negative x 1, 5 minus x 2, 5 plus x equals, it's that easy. That's the only difference between that and transportation. Those center nodes are all equal to 0, and you got positive and negative depending on which you decide. As long as you're consistent with the center nodes. Now, the objective function. How many variables will be in the objective function? I gotta look. Hang on. Okay, go ahead. How many? 12. 12 arcs. So that's how many variables you're going to have. But in the objective function, you include their costs. And then it's either a min or a max. Whatever number this is, times x 1, 3, plus whatever number that is, x. You don't have to use any negative variables whatsoever in this whole problem, except for the constraints for these middle nodes. That's it. Don't put negative variables in your objective function. Just these three constraints. Are you ready? Let's see how we're doing on time. Okay, starting to pack up on me. Not even time. Here we go. Blah, 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 blah. 3 firms. Our customers, Z, H, and R, they want shelves. And we get our shelves from 2 manufacturers. I better make sure you're getting this. We're getting our shelves from 2 manufacturers, and we have 3 customers that we take the shelves, we split them up from our manufacturer, we get them ready, and then we take them to our customers. We are the middle. We're the middle. Here's our 2 manufacturers out here. This is us. I don't know how many locations we have yet. But we have 3 customers we're trying to get these shelves for. We do something special with the shelves while we have them, and then we get them out, we customize them, whatever has to be done. Currently, weekly demand from our users are, let's see, this was Z, this was H, this is R, we'll number it in a minute, and this is 50, this is 60, and this one's 40 is our demand, right? And both of our suppliers, Arnold and Supershell, can supply up to 75 units each during this period that we're talking about. Do we have enough to supply over here? If we didn't, we'd have to add a dummy to make sure supply so we can figure out who gets the back order. But we have 150 here, and this adds up to 150, so we're okay. And how many locations do we have? Does it say? Our north side and south side facilities. So we have 2. We have 2 facilities. Here's our north side, here's our south side. To make it easy, I'm going to number now. I'm going to go 1, 2, 3, 4, 5, 6, 7. I got to find out if we can get, if both our north and south side could get received goods from either supplier, so I know how many arcs. And can we go from either our north and south side to our customers, or is there one that we can't go from one location? Sure enough, here's our manufacturers, our suppliers, here's us, and it looks like it doesn't matter. Each supplier could supply either one of our locations. So I'm going here, 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 here. I might as well throw my costs on. $5 if I go from there, $8, and then 7 and 4. There we go. This is us, north and south location. We have relationships with all 3 customers, so it could come from either location. And here's our cost involved getting it to our. So I'm going arc here, arc here, arc here, and our costs are 1, 5, and 8. Our southern location could also go to any one of these customers. And our costs here are 3, 4, and 4. Okay? How many variables are in this problem? Let me count. Go ahead. How many variables? 10. 10 arcs. We got 4 arcs here, 6 arcs here. All right? Let's write this constraint right here using the numbers. Are you ready? X1, 1 plus, help me out,
X13.
plus x13, then what? Equals,
Wait.
wait,
Where'd you get x11?
I numbered it 1,
2,
2,
3.
3, uh-oh.
So X13.
Uh-oh. That's what you're trying to say.
Yeah.
x13 plus x14. 1, 4. Now what's next? No, stop. We're on this node right here.
Less
Than equal to
75.
75. x13 plus x14 less than equal to 75. x23 plus x24 less than equal to 75. Forget the middle nodes for a minute. I'll let everybody's got their head down, they're writing. I want to do one of our customers now. How many arcs are on 0? This first customer up here, whatever they're called. 3. Is there 3 arcs?
No.
2 arcs. You ready? X 3 5 plus x
4, 5.
4 5 equals 50. It's too easy, isn't it? Have you ever had anything this easy? Equals 60, equals 40, 2 variables, right? Okay, when everyone's ready, we're doing the center one now. Everything going in, let's make it positive this time. I'm looking at it, here we go. x13 plus x, help me out, 2, 3, minus x, 3, 5 I heard, minus x, 3, 6 minus x, 3, 7 equals 0. We all follow the arcs. x13 plus x23 minus x35 minus x36 minus x37 equals 0. I think everybody's getting this. Some people are even getting bored. The objective function. These are all our costs to get it from our supplier and get it to our customers. Min or max? Min. Just do a few of these variables. Ready? 5 times x 13 plus 8 times x 14 plus so on, so on. You would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these would be your objective function. And it should look like, there's our objective function, 5, 8, 7, 4, 1, 5, da 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 da. Here's our constraints, less than equal 75, less than equal 50, 60, 40, equals 0. The ones coming in are positive, in this particular case, 1, 3, 2, 3, minus 3, 5, 3, 6, 3, 7. Look at the other center nodes. Consistency. The ones coming in are positive, the ones leaving are negative. And this could be the opposite way, but these have to be consistent. All center nodes have to be consistent, whichever direction you decide to go, after which is negative and positive. How do we feel? All right, I will have a great vacation. I know I'm going to try. So I will see you in about a week and a half. And vacation has begun.
Close to. Quick question, because I was looking over this.